In this video, we're going to be solving applied problems involving rate, time, and work, and we're going to go through several examples. So this first one, we are told that a painter can paint a house in 6 days. So let's just call him Painter A. He can paint one house in every 6 days. And this is his rate. A rate is generally something per unit time. So he can do one house in 6 days. Another painter, we'll call him Painter B, takes 8 days to paint the same house. So his rate is one house for every 8 days. And we want to know, if they work together, how much time will it take them to paint the house? So a lot of times people think that what I should do is take the 6 and take the 8 and average them. And that would mean it would take them 7 days. However, if you think about it, this painter by himself can do it in 6 days. So if he gets any help at all, even if the other guy is slower than him, it's going to take him less time. So we should expect that our answer is going to be less than 6 days. And let's look at the equation we need to use to figure that out. We figure it out by taking the work that Painter A did, and we add it to the work that Painter B did, and it all adds up to one job being complete. But we need to know what the work is. Work is rate times time, and these fractions were rates. So that's a rate and that's a rate. So we can replace work of Painter A with rate of Painter A times time that Painter A spent painting. And then same thing with worker B. His rate times his time. And that adds up to one job complete. Worker A's rate is one house in 6 days. So I'm going to say his rate is 1/6. And we don't know how long it's going to take him to paint the house. Yes, we know it takes him 6 days, but that's if he's working by himself. If he's working with someone else, it's going to take him less than 6 days. Worker B's rate is one house in 8 days, so 1/8. And we don't know his time either, how long it's going to take him to complete the job. However, what we do know is since they're working together, it's going to take them each the same amount of time, because once one person's done, that means the house is painted, and the other person must be done as well. So we don't know what his time is, but we know it's the same as worker A. So our equation simplifies to 1/6 t plus 1/8 t equals 1. And there's different ways that you can approach this. You could do clearing the denominators. You could find the least common denominator and add the fractions. It doesn't matter whichever way appeals to you is how you should do it. What I did is I found a common denominator. So 1/6, I changed that to 4/24. And then 1/8, I changed that to 3/24. And then left 1 by itself. So this adds to 7/24. And we get 7/24t equals 1. Now we want to solve for t, and we see that it is multiplied by 7 and divided by 24. Another way to write this would be like this. We want t by itself, so I'm going to undo what was done to it. It was divided by 24, so I'm going to multiply by 24. And if I do it to this side, I have to do it to this side. And that gives me 7t equals 1 times 24, which is 24. And then final step, 7 is multiplied by t, so I'm going to divide both sides by 7. and we get T equals 24/7. And if we report that as a decimal, it's going to take them 3.43 days to paint the house. Let's look at another example. A tank has 2 pipes entering. So we have pipe 1. So we'll just label that P sub 1 for pipe 1. It can fill the tank in 4 minutes. And then pipe 2, let's put it over here. Here's pipe 2. It can fill the tank in 12 minutes. So if the tank is full here, it's going to take this pipe 4 minutes, this pipe 12 minutes. How much time does it take to fill the tank if both pipes are operating? So we know that since pipe 1 can fill it in 4 minutes, if he has any help at all, it's going to take less than 4 minutes for the tank to get full. So we're expecting to see an answer less than 4 minutes. Let me remind you of the equation. The equation is the rate of the first pipe times the time of the first pipe. And then we add it to the rate of the second pipe times the time it's going to take the second pipe. And that equals 1 job. And in this case, it's 1 tank that's full. Another thing that we know is this time and this time, whatever they are, they're going to be the same. Because once the tank is full, both pipes have finished the job. So really, we don't need the sub 1 and sub 2. All right, the rate of 1, it can fill 1 tank in 4 minutes. So the rate is 1/4, and that's times time. For pipe 2, the rate is 1 tank in 12 minutes times time. We could multiply everything through by 12. This is the clearing the denominators technique. And we get 12 times 1/4, so that's 12 divided by 4, which is 3. Here we get 12 times 1/12, which is 12 divided by 12, or 1. So 1 times t is simply t. And then 1 times 12 is 12. 3t plus 1t is 4t, and that equals 12. Final step, we're going to divide by 4. And t equals 3 minutes. So when these 2 pipes are working together, it's going to take 3 minutes for them to fill the tank. Let's look at another example. We have the same situation where we have a tank that needs to be filled, and we have pipe 1 filling it in 1 hour. But now our second pipe is not filling the tank, it can empty the tank. So I'm going to put the pipe down here. Pipe 2 can empty the tank in 1 hour, 15 minutes. We want to know if both pipes are operating at the same time, how long will it be for the tank to be full? So let me remind you of the equation. It's rate 1 times time plus rate 2 times time equals 1. However, this is true if your 2 pipes are working together. So this was the equation for the previous problem because both of the pipes were filling the tank. In this case, our second pipe is not filling the tank, it's emptying the tank. So rather than adding these together, we're going to subtract. So the equation we want to use for this problem is very similar, except we're going to subtract the work that pipe 2 is doing. Pipe 1's rate is 1 fill for every 1 hour. And then that's times time. Pipe 2 is 1 fill for every, and you'll see this isn't just hours, So we'll want to convert into hours. 15 divided by 60 would give us 0.25. So 1 hour 15 minutes is 1.25 hours. Okay, at this point you have different ways you could solve this problem. What I chose to do was multiply everything by 1.25. So this is 1t times 1.25. That gives me 1.25t. Here I have 1.25 times the fraction 1 over 1.25, which would be 1t, or just t. And here I have 1 times 1.25, or 1.25. All right, this is 1t. 1.25t minus 1t is 0.25t equals 1.25. And then finally, 0.25, I'm going to divide both sides by 0.25. Cancels here. And I end up, excuse me, I end up with t equals 5. And the units on that were hours. So pipe 1 can fill this tank in 1 hour. However, pipe 2 is emptying the tank in just over an hour. So rather than taking just 1 hour to fill this tank, it's going to take 5 hours because this pipe is working in opposition to this pipe here. One final example. Again, we have a tank. And we have 2 pipes entering it. So let's say this is pipe 1. This is pipe 2. Here's our 2 pipes entering. And we have 1 leaving it. So we'll say that's pipe 3. Pipe 1 fills the tank in 3 minutes. Pipe 2 takes 7 minutes. But pipe 3 empties the tank in 21 minutes. So we want to know how much time does it take to fill up the tank. So if it was just these 2 pipes working together, we would say, well, this one is the faster one. It can fill it in 3 minutes. It's receiving some help, so it's going to be less than 3 minutes. But we have to take into account we have a pipe that's slowly draining the tank. So we're going to do rate 1 times time plus rate 2 times time minus rate 3 times time. And again, we're subtracting here because this pipe is working in opposition to these 2 pipes. And this all equals 1 complete job, or 1 tank full. Our rate for pipe 1 is 1 fill in 3 minutes. Our rate for pipe 2 is 1 fill in 7 minutes. And our rate for pipe 3 is 1 empty in 21 minutes. The way, the way I solved this problem was I came up with a least common denominator, which would be 21. So this fraction would change to 7 over 21. This fraction would change to 3 over 21. And then this fraction, of course, would stay the same. Oops, that's a t. That's a t, and they're added together. All right, so 7 plus 3 is 10, minus 1 is 9. Next step, I want to get rid of that 21. It's divided by 21, so I'm going to multiply both sides by 21. That 21 goes away. We have 9t equals 1 times 21. And then final step, I'm going to divide by 9. And I get t equals 21 over 9. However, in decimal form, that would be 2.33 minutes. Now, one final point. This was the answer to this problem, but one final point about problems where you have things working in opposition. if you got down to your final answer and you saw that your time was negative, what that is indicating to you is this pipe here is draining the tank faster than these pipes can fill it, and therefore you're never going to be able to fill the tank. So if you are doing your math and you're sure you have it all correct and you keep ending up with a negative down here, that's what's going on. So your tank would never be able to be filled in this case.